explorers, and welcome to another video. Today we are going to talk about crush rules and crush placement. So crush is pretty much a system which a bunch of scientists came up with in order to get a pretty much equal distribution over a very heterogeneous system, and it's trying to answer the question of what, where, how much, and how safe. So if we look here over at my screen, we have this cluster with 3 nodes, and if I run a Ceph OSD tree, I will see how they are interconnected. So in this case, I have this root here, default, which has a weight of 0.5727, and that is pretty much in terabytes how much is saved, and then how they are stacking up against the different nodes here. And the weight for each of these are 1, 1, 1, so we should have it equally distributed over all of them. And you see here at this root has 2 hosts under it, and then we have 1 rack with 1 host in it. So we see that there is some kind of structure here. And the structure that is available is that you can have an OSD in a host, that could be in a chassis, that could be in a rack, that could be in a row of racks, or it could be on one power distribution unit, PDU. So if you want to keep it safe, if one power distribution node goes down, then you don't want to lose all your data, of course. Then you might want to spread it out over multiple of those. You can have it over pods. You can have it, and pods is in the server term, larger sections of the server room. And then you have rooms that you can split it up into, data centers, zones, regions, and last but not least we have the root. So we can build a very large structure with a lot of different dependencies here, and then we can create some safety rules over these kind of structures. So what we want to do is create different buckets here. So what I could do is create one bucket here called rack 1 and say that that is a rack. This could be also A1 room, for instance, if we have a room called A1. So it could be pretty much anything, and then specify what type it should be. And then we could move things around in our structure here. So if we have, let's say, this host that I call host 1. So in my case I have N1, N3, N1 and so on. But I can take this host and say that this host is located in a data center, DC1, in a room, room 1, row 1, and then rack 1. So then I have specified very strictly where this should be located, this specific host. So I can move hosts around. Of course, if we add something, we can remove it as well. So if I want to remove rack 1, I can do that. Now, if we want to say that we want to have a specific computer, in this case, a specific host, and say that this should be located in a specific place, depending on the different variables and so on, then we can make it much easier for ourselves. There is, of course, a bunch of these scripts that deploy servers all over the place, but let's say that we don't use any of those. We want to do something manually, then we need some kind of configuration. And if we look in our Ceph configuration file here, I have this crush location. And crush location could be defined statically, so I can say that this host is located here. So I can say crush location equals to rack equals rack 1, host equals N1, and then default, a root equals default or something like that. And I can have it separated by either spaces or commas, semicolons, or tabs. So depending on how you want to set this up, you can create a location here. But I wanted to take this one step further. So I said I want this crush location hook, which is a program. So this program I have created, and if we edit this one, and it's located in the Ceph directory, just so the Ceph application has the rights to run it, pretty much. So you need to give the Ceph user access to this one. So if we go into this, and in here I want to add something. First off, I want to add the definition that we want. So let's add this definition. And here I say that echo out to screen, so only one definition I will echo out. I will say that host will be this host name, just give it the server name. And then I want the rack equals to whatever is typed in etc rack. And then I say that root should be default. So that is the location of this specific server. So if I say that, and then I check that I have an etc rack, and that is rack 2. So you could create this file, you could have some system that creates rack information on your system, or you can have some specific command that gives you that information back. This is just an example here. Now I have a rack specified, and I have this crush location script that I can run. So next up, I will make this executable, of course. So let's do that. Now it's executable. So if I run it, we will get this information here, host n2 rack 2 root default. Then I want to make it owned by Ceph. So Ceph is allowed to run this script. I will do that. So now it can run and the configuration can take it up. The problem here now is that if I create new OSDs, it will look this location up and then put the OSD there. But if we look at our tree again here, OSD tree, we see that we have a host 2 already. So if it looks at the granularity here, it figures out that there is already a definition for where host 2 is. So let's put the hard drive there. And that is not what I want here. So let's say that we will remove this node 2. So that is OSD2. I will stop OSD2. And then after I've stopped it, I will remove it. So I will purge it out of the system. And then I will zap that drive. So I destroy all data. This is something that you should do very securely, of course. You should be very sure what you're doing when you're removing stuff. But this is just an example. Now, if I were to create this again, it would not have moved place because the host 2 is already defined here. So I can't just move it over or create it again and it will move, because if anything is defined in a specific way, it will be kept that way. So it will not make any large data movements if you are creating new things. So what I need to do now is actually run remove and then remove host 2 from my crush rule. So now I have a tree where node 2 isn't available. If I now go in and prepare a new drive, this SDB, and create that, it will create a new one. And because I purged it, ID2 is already available again, so I can reuse that. So I will activate ID2 with the specific UUID. And when I do that, if I go back and look at my tree, I see now that I have this OSD2, it's down, it will be starting up. And when it started up, it put itself in rack 2. So the only way to actually create a structure from this is if nothing is defined before for this specific host, then it can define it when it creates new drives. So keep that in mind if you want to deploy this in a larger sense and want multiple of them. So now I will deploy a bunch of more drives here. I will deploy 2 more drives. I will deploy SDC on this host, and it got ID 3. So let's wait for that, and then 3, and take this here. So these drives, they are virtual drives, small ones, but they are defined as solid state. And that is another thing we can specify in this system. What? So I will create these solid state drives, 2 of them, and activate them. So activate 4 with this UUID. So now that I have specified that, we can check our tree again. Ceph OSD 3. We see that I have 2 OSDs down here. Both of those are SSDs. So that is a different way you can write rules. You can write rules depending on how the actual infrastructure or network is set up, the Crush network, or you can define it depending on what type it is. So if we go back here again, you could move a specific OSD over from somewhere. So as we see now, we have the OSD 0 on host 3 rack 3, and I could, even though it's a little bit weird, you could move this around. So if you set that OSD 0 1 should be in rack 2, host N2 root default, it will move over to that host, which makes no sense because that's a different server pretty much. And I can move it easily back as well. I don't need to specify everything here as everything is set up already, so I can move it back so it's down here. But on the other hand, if I were to say that this should not be a part of the crush rules, I should put this OSD out for some reason. I don't want it to be a part of the map at all. I can do that, and then you see that nothing is assigned to this server down here. It will have nothing on it. And in order to get it back, I can do the same as I did before with the rack here. But I will do an add instead. So I will add it in, saying it should have weight 1, and put it into the crush map. And if I do that, then we have the old tree back again with the right balance. And if we look at the next part here, we can set up a device class. And currently every one of these has device classes. So we have an SSD, we have an HDD, and so on. But we might say that we want to remove one of the classes on, for instance, OSD 4, because that is incorrect. And in order to change it, you need to remove it. So if we remove it, we see now that this OSD 4 doesn't have a class anymore. Then I can set my own class. So if I do like this, I can say that this should be an NVMe drive, and it will get that definition instead. Usually, if you have an NVMe drive in your system, it will already be identified as NVMe, and you don't need to change that class. But you could say that I want to set the Samsung class on all my Samsung drives because I want to have them separated in some way and just save some data on those drives. Or you can have some drives that are really good at saving data for long term, but they are slow. But you can have other drives that are faster and you want to have those in top. Then you could say that you have slow and fast drives instead as a classification. But that's the difference, so you can have what it is and where it is. Now, if we look at the rule that is available, so we can say OSD crush rule ls. So we have this replication rule. We can show that replication rule as well if we want more information about it. Let's see, a dump is the name. Then we will get the information about this specific role. It's a replication rule. It will take from the default pool, and it will choose depending on host. So the security domain is host. So if you set this up, you say that if I were to say that I should replicate things over host and I should have 3 copies, then each host if you have a cluster of 3, then each of these hosts should have 1 copy each. So you shouldn't have all 3 copies on one host. That doesn't make sense. Of course, you can change this up. So we can create a new rule here. We do that by Ceph OSD crush rule create replicated, and I created a rule called rack split default rack. And if I do that, I will have something that has the safety domain, security domain will be over rack. So if I want to say that all the hosts in the different racks should have at least 1 copy. So there shouldn't be 2 copies in one rack. It should be in different racks. Then I can use the split here. And of course you can go even further and say that I want the specific default host, to be in different data centers. So you have 1 copy in each data center, for instance. But we can also have something like this. So this is the NVMe drives. I say that I want a crush rule, created, replicated. I want it to be over different hosts, but I only want to use the NVMe drives. So this is a specific classification that I want to use for this crush rule. Of course, there is a command that we can remove a rule as well, if we want. So let's remove this rack split. And if I now do like this, that I say that I will use this NVMe drives, then I can run this command, set a specific rule on a pool. And let's say that we look at so if we look at our cluster now, we see that we have this set up here with 3 different pools. I could add the crush rule set here, so you see what rule set we have. So we should have 3 different replicas and so on. But if I want, I now can take this replica rule and change it up. So let's do a little bit more work here. Let's go back here and go into the different hosts. And we are back, and I've done some changes here. First off, as the weight is set in terabytes, I needed to change this HDD to 0.019019, and this is because it's a 20 gigabyte disk, more or less. So here we see also that I have added a bunch of new drives here on the different hosts, and I set some of them to NVMe. So now we have 3 NVMe, 3 SSD, 3 HDD. And what I can do now, as we have this failover domain, I can go in and look at our setup here. And if we look at OSDs, we will see that we have a bunch of data separated on the different drives here. We have a little bit more on some of the NVMe drives because these are smaller drives, and then we have larger drives up here. But it's not super weighted, and that is to be expected because the system will do a random distribution that is more or less correct over the system that you have set up. So it's not perfect, but the distribution is at least somewhat equal over what you have here. But if we look at the pools, we see that the largest pool is of course the data pool, and then we have the Cephfs. I will do something here that is not really intuitive, but I will say that this data pool will run on the NVMe drives instead. It should fit. So we go here, NVMe drives, and I say Cephfs data. So change that over to that specific crush rule that we created with MVME drives. So if we go back here, we see that the crush rule is MVME drives instead, and we will have a bunch of data migration. It says that misplaced 70% of the data, and we have some throughput here moving data over. And if we look at OSDs, we see here that much more of the placement groups were put on the MVMEs, and the data on the MVMEs is moving over, and it gets a lot more data on those, while the other ones are shrinking. And in case of where you say that you want to have a specific cache pool, for instance, then it could be good to say that that cache pool should be on your fastest drive, for instance. So that's where you set up these kind of crush rules and say that I want the fast drive to handle this. And then you have this failover domain saying that it should be separated on different hosts. But you could, of course, have a failure domain that is over different power distribution units, so you can feel safer there, or different data centers, depending on how large your structure is, or how large your cluster is, and of course, what is your failure rate, pretty much. So if you have multiple data centers, of course, you don't want all your eggs in one data center if that data center disappears from the earth. So the failure over domain should of course be on different data centers. So this was what I wanted to cover today. There is a bunch of more advanced ways of using crush rules, way that you can say I want 1 copy on these kind of drives and I want 10 copies on these kind of drives and so on. So you can set up very particular rules around this, but I think this is the basic things that you need to know about crush rules, how to set them up, how to handle failover domains, how to define the location of your different OSDs, and how to set up rules that either are depending on location, your failure domain, or depending on what kind of device you have and how they should be weighted. So I hope that you found this interesting. I hope that you learned something today. If you have any questions or suggestions, leave them down in the comment section down below. If you haven't subscribed yet, please do that. And if you like this video, give it a like, share it with your friends and colleagues, and I really hope to see you in the next video.